run the same analysis that we used to do with Sarah. We also do it using ARA. So to use ARA using Google Colab, you just search there. You can search Google Colab. Then when you search Google Colab, you just click there. But yeah, so it brings you to a page. So Google Colab is like an environment that you use. You can use ARA. It uses sometimes ARA commands, or it can also use Python. So by default, there you create a new. But then by default, when you create a new notebook, you realize that it uses Python. It learns in Python. So you first have to change it. So you change it using learn type, then change learn type, then you set it to ARA so that it recognizes ARA commands. So therefore you save. Now therefore you can continue to what? To learn the word. So the first command is to dive auth. This is to give an authorization in ARA to say you should be able to log in into the Google Drive, because you have to understand that for this Google Colab, in order to learn, it will have to recognize the datasets that you uploaded in the Google Drive. So you learn drive auth, you give an authorization for it to access ARA Google Drive. Once that's done, there are several like for instance, I can just demonstrate what happens. There are several verifications you have to do. I do this, and then I click learn, and make sure when you are doing this, you are connected to internet. So just that I'm having slow internet here. That's why you see that it's taking a bit of time. But you have to make sure that you have access to strong internet. So I already have the analysis. Now when you do that, it brings you a certain box so that so that you run that. Now there you continue. There's a link that they are given, and then that link takes you to a certain your account so that you verify. So once all the verifications are done, it means now ARA recognizes your drive, and then you continue with it. So there is step 2, download the CVS file. For you, after ARA recognizes that you have a Google Drive and all the datasets are there, you have to download the actual dataset that you're going to use. In this case, we are given students data. Now, we have to convert this data into CSV file. So now we'll tell the we'll write a command file drive get so that it gets the students data and downloads it into the environment. You can even, so we did step 3, we did load it just to check through the variables, what is contained in the data. As you can see here, we have all the variables, the secondary school, the age, and the program. So we did just check part of it. Now we had to learn, as a first step, we had to run the summary statistic. Remember, we're just doing a recap of what we did in Starter, but now we are just using Google Colab. Now running a summary statistic, we are given the mode, the median for age, and all other variables that are present in the dataset. We also did run install. We did so Woodridge. This is wage 1 that was given, but we chose to take it from the Woodridge because we understand package Woodridge has dataset called wage 1. So we had to install it. After installing it, we tell this to run it, library Woodridge, and then data wage 1. So now that Google Colab recognizes that we have Woodridge and wage 1 as our dataset, we can run OLS regression. We continue to run OLS regression by OLS model. So we learn to check how wage is affected by education, experience, tenure, and data. I mean, yeah, and no others. So we continue from there to learn the Summer OS model. That's just to show the results. So we can see our intercepts there, the standard errors, education at 0.59, experience and tenure. So we continue from there to run diagnostics, checking for heteroscedasticity and mitochondriality as well. So we store a package in term. This helps us to check, so that it helps us to, as we are running the wireless model, it uses a package in test. So we run that package, and once after it's installed, we run the test. Now to continue from there, we also did learn some logistic tests. Here we have some results from the model. P-value of 2 point, which means that we reject the null hypothesis. We also have some, so reject the null hypothesis shows that this data has presence of heteroscedasticity since our p-value is greater than 0.05. We do not stop there, and then we continue to run some logic model. So it uses a package called mass. So we had to first install that package and then recognize the data birth weight. So from there we can also see our estimates: -1, -0, 0, and smoke, which means most of our water is being affected as -0 from 0. And a decrease in year of age, there's a lesser chance of the mother having a birth weight. And so we also did learn some probit model here to check the latent, the latent. So probit model, as we all know, it uses a standard normal distribution. So probit model uses standard normal distribution. From there, we have to check. We can see that we have a weight of negative, coefficient weight negative 3.4, mileage is negative 0.16, and that we continue from there. So we also had to finish up with step 10 by learning the marginal effect of logistic model and also marginal effect of probit model, which shows us our results that the first ones are for what? For the logistic model and also probit model. You can see that there are certain variations here. So it tells us what a change in age will result into a lesser chance of the what? Lesser chance of the mother having birth weight. A change in the less or an increase in the less of the mother is resulted into an increase of by probably 11% chance of the mother having what? Birth weight. Same with smoke having a percentage change of 24%. The same thing, we run the marginal effect for probit model, and we see that there's a lesser chance of that car being a fallen if it has a weight of about 10%. So there's a 10% less chance of that car being a fallen. The same way, if a car has a less mileage, there's probably a lesser chance of about 4.9% of that car being fallen. So this was basically our analysis using star, using using ARA on Google Colab. Thank you very much.